This trick will ensure that I basically am able to collect terms and will allow me to basically reduce this whole concept down to something a lot simpler than the summation of 12 different terms. So when I distribute, because multiplication occurs in any order, is commutative, what I'll get here is when I distribute it to the first term is 50 times 1.01, not 11, but now 12 times. Similarly, I'll get for the next term 50 times 1.01 to the 11th. So every single term will basically just have an increased exponent of 1. So by the time I get down to the final term here, I'll have 50 times 1.01 to the first power. So notice that all I've really done is I've increased all the powers by 1. Well, what that allows me to do is now take a look at this. Whenever I subtract 1.01a and a, that is this guy and this guy, subtract a from 1.01a, well, that's the same thing as subtracting this whole thing minus this whole thing. So what I would get is 50 times 1.01 to the 11th power, 12th power, excuse me, plus 50 times 1.01 to the 11th power, plus all the way down to 50 times 1.01 to the first power. Okay, now I'm subtracting from that this whole set of terms right here. So this is going to be 50 times 1.01 to the 11th power. I'm just lining things up because I don't have a 12th power up here, plus all the way down to 50 times 1.01 to the first power, plus 50 times 1.01 to the 0th power. So notice that all of these terms in between, this guy would cancel since I'm subtracting all of these guys away from this guy, and all the way down the line we'd have cancellations except for what we'd have left, which is the first term of 1.01a, because there's not anything to subtract here, and also I have an extra 50 times 1.01 to the 0 power. So I have 50 times 1.01 to the 0 power, and that's minus because I'm subtracting away the second set of expressions from the first. So what have I proven? Well, all I have left now because of this trick is 1.01a minus a equals 50 times 1.01 to the 12th minus 50 times 1.01 to the 0. Okay, well what I'm going to do is I'm going to solve for a. The reason I'm going to solve for a is because I want a shortcut method, and I can see that already this is a much easier way to compute than having to do 12 terms summed together separately. So 1.01a minus 1a would just leave me with 0.01a. That's the difference between those. 1.01 minus 1 equals 50 times 1.01 to the 12th minus 50 times 1.01 to the 0. Okay, well, to solve for a, I'm going to divide both sides. So our little trick is paying off here. Basically, now I know that a, the accumulated amount after 1 year, can be calculated simply by 50 times 1.01 to the 12th minus 50 times 1.01 to the 0 all over 0.01. If I do a little bit of cleanup work at the top, I would have 50 times 1.01 to the 12th minus 1.01 to the 0 power, all over 0.01. Finally, 1.01 to the 0 power is just 1, because anything non-zero raised to the 0 power is 1. So I end up with the following expression. Okay, so why did we do all of this? That was obviously a lot of little algebraic tricks in there involved to get to this point, but all in good